Hi guys, so today we're going to review some exponent properties and some radical properties, and then we're going to use those properties on rational exponents and then roots that are higher than just a square root, like a cube root or a fourth root. So to start, we're just going to review some powers, and these are ones that you need to know really quickly, really easy, and be very familiar with. Ones that you know, kind of like your multiplication facts. So 2 squared is 4, 2 to the third is 8, 16, 32, and 64. 3 squared is 9, 3 to the third is 27, 3 to the fourth is 81, 4 squared is 16, 4 to the third is 64, 4 to the fourth is 256, then we've got 25, 125, 625, and then 6 squared, 7 squared, etc. I'm not going to get into all those, but maybe some of the ones you may not remember would be like 14 squared, which is 196, or 15 squared, which is 225. And then 10 to the anything, okay, if it's 10 to the 10th, that just means there's a 1 with 10 zeros. 10 to the 4th is a 1 with 4 zeros. So that's why it's anything, because that's just the number of zeros that will follow. All right, so then reviewing those properties, these are what you had on that review assignment that you guys had. So the square root of 32, depending on the method you use, that will break down, we can take out the square root of 16, so that'd be 4 root 2. Negative exponents, move it to the other side of a fraction. So this is 1 over 4 squared, which is 1 over 16. 4 to the 1/2 is the square root of 4, and we're going to get more into that today. So if you didn't know that one ahead of time, that's okay. Negative 7 squared is a negative 49, whereas negative 7 in parentheses is a positive 49. All right, when we have our exponents, if we have the same base, we can add those exponents together when we are multiplying them. When we have a power raised to a power, that's when we multiply the exponents. Then if we have exponents top and bottom of a fraction, that's when we subtract. And again, the larger y value was in the bottom, so we kept our answer on the bottom. Power to a power of a fraction, they both get that exponent. Negative exponent that applies to both, and it actually just flips that whole fraction. So then both of those get that exponent, so this would be y to the third over x to the sixth. With radicals, if they have the same number under the root, we can add them together. With multiplying, they don't have to have the same number under the radical. We multiply the outside numbers together, keep them outside. Multiply inside numbers together, keep them inside. Then to rationalize, we multiply by that root top and bottom, which gives me the square root of 2 over 2. All right, so that's just a quick review of some of your exponent properties and radical properties. Again, you can look back over that review assignment that we had, and that's got a lot more practice on these. All right, so now we're going to look at rational exponents. So rational exponents are basically our fraction exponents. The way it works, whenever you have a rational exponent, the bottom number of that fraction is the root that you are taking. The top number of that fraction is the power that you are raising to. And kind of the easy way to remember is that, think about trees. Trees have roots, and the roots are at the bottom, okay? So the root is the bottom number. So x to the 3/4 is the fourth root of x to the third power. Now you could write that like this, or you could write it with x to the third on the inside. Either way, you're going to get the same answer. All right, again, y to the 7/9, same idea, that the bottom number of the fraction is the root. So this is the 9th root of y to the 7th power. On C, only the y has that exponent. The x does not. So the y is going to move to the bottom. And then since it's the 1/4 power, that's going to be the fourth root of y. Now, this is good, and this is a rewritten expression. The problem here is what we're going to need to do is rationalize. Now, we're going to get more into this in some later examples, but I want to go ahead and introduce it now. So in order to rationalize, we need to not have a square root in the bottom, or a root in the bottom. Well, right now we have a fourth root. What's different, though, about these higher order roots, if I just multiply by the fourth root of y again, I'm going to get the fourth root of y squared, which I still don't know. That doesn't help me. So what I need to get, I need to multiply by something that's going to give me the fourth root of something I do know. Well, I do know the fourth root of y to the fourth. The fourth root of y to the fourth is just y, and that's what I'm trying to get to. So in order to get there, I need to think, what do I have to multiply by? Well, when I multiply those together, I add the exponents. So y times y to the third would give me y to the fourth. So this needs to be y to the third. If I multiply the bottom by that, I multiply the top by that. So that gives me x times the fourth root of y cubed. And then the bottom reduces to just y. All right, D, a little bit simpler. Okay, they're both to the 1/2 power. They both are under there, which means they both are under that square root. All right, let's move to A. So xy, it has a third for the third root to the 4th power. Both of them have it, so they are both going to be raised to the 4/3 power. But on 8, they both don't have that 4 as an exponent, only the y does. So x is actually being raised to the first. So this would be x to the 1/8 and y to the 4/8. And 4/8 can reduce to 1/2. All right, let's go to C, okay? Right now I have the cube root of -5 to the 6th power. So -5 has an exponent, the root's on the bottom, the power's at the top. Well, 6/3 can reduce, so that's -5 squared, which is 25. All right, so now let's look at D. All right, so right now I have the 5th root of x to the 10th over y. So both of those are going to get rewritten. So this would be x to the 10/5 over y to the 1/5. Well, 10 over 5, that's just y squared. So this is good and it's equivalent, but again, we need to rationalize. Well, in order to rationalize, again, I want that whole number of y. So a y that I know would be 5/5, because that reduces just regular old 1. Well, in order to get there, I would need to multiply by y to the 4/5. Because again, when you multiply those like bases, that's when you get, you add those. So 1/5 plus 4/5 would be 5/5. So multiply top and bottom. So this would be x squared, y to the 4/5 over just regular old y. All right, so now we're going to apply these properties just to some values and actually evaluate some things. So first one on here, 27 to the 4/3 power. Okay, so again, remember the bottom number of that exponent is the root. So we're going to take the cube root of 27. The cube root of 27 is 3. The top number is the power, so 3 to the 4th power is 81. All right, on B, again, we're going to take the 4th root of 16 and raise it to the 5th power. The 4th root of 16 is 2. Raise it to the 5th power, and I get 32. All right, 4 to the 1/2, hopefully pretty simple. That's just the square root of 4, which is 2. All right, then 4 to the -2nd power. All right, now we did negative exponents earlier, and it wasn't that bad. But once we start throwing in these fraction exponents, negative exponents tend to get missed. And I think that's because negative exponents flip into fractions, and then they sometimes get confused with those fraction exponents. So 4 to the -2nd is 1 over 4 to the 2nd. So that's 1 over 16. So 4 to the -1/2. Okay, this combines both of these properties together. So negative exponent moves it to the bottom. 4 to the 1/2, that's the square root. So the square root of 4, and that's 1/2. All right, looking at F, again, combining both of those properties together. So negative exponent moves it to the bottom. 1 over 9 to the 3/2. So to do 9 to the 3/2, that's the square root of 9 to the 3rd power. So I get 1 over 27. All right, looking at G, the 6th root of this number. Well, I've got 1, 2, 3, 4, 5, 6 zeros. So that gives me a clue that that's going to be negative 10. The next one is a little bit different. That number that's in parentheses is negative. Well, if we were dealing with square roots, I couldn't do the square root of negative 10 or negative 100. It became imaginary. Because we can't do a negative times a negative an even number of times and ever get a negative. So just like square roots, we can never take a sixth root of a negative. In fact, we can never take an even root of a negative. So this one is not real. All right, whereas I, the fifth root of this negative number, that is possible. Because you can do a negative times a negative times a negative times a negative times a negative and still get a negative answer. So this is negative 10. All right, so now we're going to move on to do some exponent properties again. Now, this is nothing more than what we did on our review activity. The only difference is we're dealing with fractions, which makes it a little bit harder, and then we're also going to need to rationalize. So x to the negative 1 is going to move to the bottom of the fraction. Now, the 3, that's not going to move, okay, because that does not have a negative exponent. But we are going to move that x to the first power down. Now, in order to combine those two things together, I need to have a common denominator. Well, x to the first, that is x to the 5 over 5. Now I can combine those together because they have the same denominator. And I get 3 over x to the 8/5. Now again, we need to rationalize. So I need to multiply by x to the something, probably over 5, so that I get x to the whole number. Well, something over 5 that's a whole number would be 10 over 5. So in order to get 10 over 5, I would need to multiply by 2/5. So that gives me at the top 3x to the 2/5. And at the bottom now, that gives me 10/5. 10/5 just reduces to a regular old x squared. All right, looking at b. b, we have a power to a power. And when we have a power to a power, we multiply those exponents. So this would be 27 over 8. And then I'd multiply those exponents. So 1/4 times negative 4/3 gives me negative 1/3. Now, negative 1/3, we're going to actually evaluate that. Negative exponent, I flip my fraction. And then I'm going to take the cube root of both those things. Well, the cube root of 8 is 2. The cube root of 27 is 3. All right, then looking at this last one, again, using our exponent properties. So looking at my x's, okay, I can combine those together as long as I add those exponents and I get a common denominator. Well, that denominator needs to be 9. So I'm going to change 2/3 to 6 over 9. Now I can add those together and I get x to the 11 over 9. Then I can combine the y's. Again, we need a common denominator. My common denominator is 15. So this would be 3 over 15 and 5 over 15. The larger one's on the bottom, so I'll do 5 over 15 minus 3 over 15, and that's 2 over 15. Then the last thing I need to do is rationalize. So times y to the something, and I want to get a whole number. So I want this to be 15 over 15. Well, in order to get that, I'm going to need to multiply by y to the 13 over 15. Because again, top and bottom. So this gives me x to the 11/9, y to the 13/15 over regular old y. All right, so now we're going to transition and look more at radical properties. So what's nice about these is all of the same properties we use for square roots are going to apply. The only thing that's different now is we need to ensure that it's the same type of root. Because with square root, that's all we had. It was always square root. But now we're going to start combining cube roots and fourth roots and things like that. So what we can't do is take a cube root and a fourth root and just multiply them together like it's nothing. They need to both be cube roots or both be fourth roots, or we need to rewrite them in some way so that they will be. So look at this first one. Those are both cube roots. So I can use the same properties that I did with square roots. Multiply the outside numbers together. Multiply the inside numbers together. Then with the inside numbers, I can take that and I can simplify that square root. Now the method that you use depends on which one was easier for you for square roots. Some of you divided up perfect squares and some of you made the factor tree. Personally, I think the factor tree on these is a little bit easier for most people, just because a lot of people don't know their perfect cubes and fourth powers as well as they know their squares. But if you know your perfect cubes, like 8, 27, 64, etc., you can still divide out your perfect cube. Well, 72 is divisible by 8. The cube root of 8 is 2. If I divide that 8 out, I'm left with 9. So I get 20 cube root of 9. That looks a little like a 3, sorry. Now the other method we could use is factor trees. So with a factor tree, I take that inside number. I take that 72. And I'm going to break it down into its prime factors. So basically, I'm going to take two numbers and multiply by 72. 8 and 9. And I'm going to keep breaking those up until I get down to prime numbers. All right, once I get down to all prime numbers, I look at all the bottom numbers. So any of these numbers. Since this is a cube root, I'm looking for sets of 3. So any number that repeats itself 3 times. And in this case, I have 3 2s. So 2 went to the outside. What was left over were my 3s. The 3s got multiplied, and they got left on the inside. So it's up to you which method makes the most sense, whichever one is easier. All right, moving on to B. So I've got 4th root of 80 over the 4th root of 5. Well, just like we could with square roots, we can just divide those numbers and make that the 4th root of 16. What's even better, we know the 4th root of 16. The 4th root of 16 is 2, because 2 times 2 times 2 times 2 is 16. All right, C just combines both those properties together. Doesn't matter the order you do this in, I can multiply and divide. So I get the cube root of 24 over the cube root of 2, which is the cube root of 12. Now the cube root of 12 does not simplify. Unlike the square root of 12, I can't break this down and get any sets of 3, only pairs. So that does not simplify. All right, let's look at the cube root of 120. So 120, again, I can either break it down with a factor tree or divide out my perfect cube. I'm going to go ahead and make a factor tree. So 12 and 10, 6 and 2, 3 and 2, and 5 and 2. So looking at the bottom numbers, all the prime numbers, I'm looking for a set of 3. Well, I've got a set of 3 2s. So 2 goes on the outside. I'm left over with a 5 and a 3. Those get multiplied on the inside. All right, moving on to E. E actually brings us back to our exponent properties. So it's kind of hard to see, but remember, if I have x squared times x to the 5th, that's x to the 7th. That's the same concept we're going to use for the numerator of this fraction, because I have the same base. They're both 16. So since they have the same base, I can combine those bases, keep that base, and then I can add those exponents together. So that becomes 16 to the 7/3. Well, now, both the top and the bottom are raised to the same power. They're both raised to the 7/3. So I can rewrite that as 16 over 2 to the 7/3. And now from there, I can even go a little bit farther. 16 over 2 is just 8. And then 8 to the 7/3, I can take the cube root of 8, which is 2, to the 7th. 2 to the 7th is 128. All right, F is actually probably one of the trickiest questions on here. Now, it's not difficult, but it's tricky. Because the way you would think to solve it is actually not necessarily the easiest way to get to your simplified answer. So on the top, we can go ahead and combine those two together. We can multiply those together and make that the cube root of 54. And then what a lot of people would do is take the bottom and rewrite that as the 6th root of 4. Now, that's not wrong, but it makes it hard to see what my final answer is going to be from this step. Because remember, we can only divide if it's the same root. And right now, I've got a cube root and a 6th root, which are not the same. So what I'm going to do instead is recognize that these have the same base. So if they have the same base, I'm going to rewrite them with rational exponents. Well, if they have the same base, I can add those exponents. So that becomes 2 to the 2/6. Well, 2/6, that reduces to 1/3. And 1/3, I can rewrite as the cube root. And if I have the same cube root, I can divide. So I get the cube root of 27, and the cube root of 27 is just 3. All right, moving on. So going to G, very similar to D. The only difference is now we also have to consider the variables. So let's start by simplifying the 4th root of 32. So let's take 32 and let's break it down. And since this is a 4th root, I'm looking for a set of 4. Well, I do have 4 2's. So 2 is going to come to the outside. There's a 2 left over. It's going to stay on the inside. Well, now we need to consider the variables as well. So x to the 6th power. X to the 6th power means x times x times x times x times x times x. So if I have 6 x's, I'm still looking for sets of 4. Well, I have one set of 4. So x to the 4th, one set comes out. So x is going to come to the outside. What's left over is 2 x's. X times x is x squared. That stays over on the inside. All right, then we move on to the y's. Y to the 5th. Again, I'm trying to see how many sets of 4 I can take out of that. Well, I can take out one set of 4. If I take out one set, I'm left with 1. Then I go to z to the 12th. Well, I can take out 3 sets, and then there won't be any left over. So that's my simplified square root. All right, if you feel comfortable, pause the video, try the next one on your own. All right, so let's start with the cube root of 40. So I'll take 40, I'll break it down. All right, so 40, I'm looking for sets of 3, and I've got a set of 3 2's. So 2 goes to the outside. 5 is left over on the inside. Then we go to our x's. I'm looking for sets of 3 because it was cube root. Well, I can take out 2 sets of 3. That leaves me with 1 left over. Y to the 12th. Okay, I'm looking for sets of 3. I can take out 4. Wouldn't leave me with any left over. Then look at z. I can take out 1 set, and that's going to leave me with 2 left over. All right, then again, adding and subtracting, we have the same root, but we don't have the same number inside, so we need to simplify. Well, cube root of 40, we just did that. The cube root of 40 is 2 cube root 5. So 2 cube root 5 plus 2 cube root 5 is 4 cube root 5. All right, so now again, we're going to revisit rationalizing. So rationalizing, like I said, is probably one of the harder things on this day. So with rationalizing with these numbers, we got to be a little bit more strategic than we are just with regular old square roots. I can't just take this and multiply by the 5th root of 8. That's going to give me the 5th root of 64. I don't know the 5th root of 64. So instead, I'm going to multiply by something that I do know. So I want a 5th root. Well, even if we don't know our 5th roots, we can get one pretty easy. If I take 2 and raise it to the 5th power, I get 32. So the 5th root of 32 is just 2. So I can get there. I need to multiply by the 5th root of something so that I end up with a 5th root of 32. So if I take the 5th root of 8 times the 5th root of 4, I'll end up with the 5th root of 32. So if I multiply the bottom, I multiply the top. And then that becomes just regular 2 on the bottom. All right, same idea on k, but now we're also introducing a variable. So cube root of 4 over the cube root of 9x. So again, think about numbers you know the cube root of. I know the cube root of 27. So I want to get to where this is the cube root of 27. Well, if I take it and multiply by the cube root of 3, that'll get me there. I also need to consider the x's, though. I don't know the cube root of x. I do know the cube root of x cubed. So in order to get there, I would have to multiply by the cube root of x squared, top and bottom. So that gives me 12x squared at the top. I can then simplify the bottom. So I get 3x on the bottom. All right, then looking at L. Again, we got the 5th root of 3 over the 5th root of 4. So a number that I know the 5th root of is 32. So in order to get there, I need the 5th root of 8. So I got the 5th root of 24 over the 5th root of 32, which is just 2. Now that we've done all this rationalizing stuff, though, don't make it harder on yourself than you need to, okay? Something like M, don't jump straight to rationalizing, okay? Remember your properties. I can divide those things. This is just the cube root of that whole expression. And I can simplify that expression using my regular old exponent properties. So I can subtract and get x to the 8th, y to the 4th. Now I don't have to worry about rationalizing because there's no longer anything in the denominator. Then I can just simplify this the same way we did earlier. So I'm looking for sets of 3. Well, I can take out 2 sets of x's, 1 set of y's, and then I'm left over with 2 x's and 1 y. All right, N and O are actually straight off your review. Multiply by the conjugate. So top and bottom by 5 minus root 3. And remember, when you multiply by the conjugate, those middle terms cancel out. So 5 root 3 minus 5 root 3 goes away. And root 3 times root 3 is just regular 3. So I end up with 5 minus root 3 over 22. All right, and then on O again, multiply by the conjugate, root 6 plus root 2. So I get root 6 plus root 2. I'll get 6 plus root 12 minus root 12 minus 2. Those cancel out. So I've got root 6 plus root 2 over 4. All right, then the last one on there actually looks more complicated than it is. I've got the same base and the same root. So I can just add those together. So that is just 12 times 9 to the 2/3 power. All right, so again, this is one, there's just a lot of little rules that you really got to be comfortable with radicals and exponents. Again, work in the homework assignment. This one's going to be really good review for your quiz.